Hi everyone, my name is Jake Hudgins, and I'm a PhD candidate in exercise physiology at the University of Kentucky. Today I'm going to be talking about the influence of running shoe type on the relationship between commercial running power and measures of metabolic demand. And so I think it makes sense to start this with first looking at power in the context of cycling, where it's been predominantly used, primarily because of the very consistent linear relationship between measures of mechanical power on the bike and the required metabolic power energy expenditure that's necessary to produce that mechanical power. As you can see here in the graph, on the x-axis we have mechanical power, on the y we have energy expenditure, metabolic power. And there's this very linear relationship, which is very consistent in between different performance levels of cyclists, low, medium, and high here. You can see there's really not much variability across these three groups. And so cycling coaches and cyclists can use this mechanical power to indicate the metabolic intensity or metabolic power required during a training session or a cycling race. Now, unfortunately, there's really not been a way to practically do this for endurance running, at least up until recently. So recently, running power meters have been developed as a potential way to indicate the metabolic demand during running, but there's been pretty limited research on them so far. There has been some research to indicate, at least under controlled conditions, that there is a similar linear relationship between this commercial running power metric and the metabolic demand. This one study by Sarasuela-Espejo showed that in both indoor and outdoor conditions across a few different body weight, speed, and incline running conditions, that there is a linear relationship between mechanical power or the commercial running power and measures of metabolic demand, in this case, oxygen consumption. So one of the things that could potentially influence this relationship, though, is shoe type. There's been pretty significant improvements in running shoe technology with carbon fiber plates and new midsole foams in the running shoes. And this one study by Gilbert and Jones actually showed that compared to the A6 Hyperspeed, a pretty traditional racing flat, that some of these new shoes with improved shoe technology can significantly improve the running economy. And this was particularly true for the Nike Alpha Fly, this black line representing the average running economy over here on the left, average running economy across these 7 different shoes compared to the A6 Hyperspeed. We see the Nike Alpha Fly improved running economy the most. So it's kind of unknown if the shoe type that has the influence on running economy would be detected by this running power device. So that was the purpose of this study, was to determine the influence of running shoe type on that relationship between commercial running power and metabolic demand. So we used 2 different types of shoes. First, a high-end racing shoe to improve running economy. We went with the Nike Alpha Fly Next%, which has been pretty consistently shown to improve running economy by about 4%. And then compared that to a low-end economical shoe that has been advertised as a running shoe, but doesn't necessarily have any performance or running economy enhancing benefits. So we hypothesized first that metabolic demand or running economy would be lower or better in the high-end racing shoe, and there wouldn't be any difference or any significant difference in running power between the 2 types of shoes. We also hypothesized that there would still be a strong relationship between running power and metabolic demand in each type of shoe. So for this study, we recruited well-trained runners that were aged 18 to 45, capable of running 10K in less than 40 minutes. We ended up with 14 runners, 13 males, 1 female, and who could run on average 10K in about 36.5 minutes. So we had 4 days of testing for this study. On days 1 and 2 was primarily for a VO2 max test or a maximal graded exercise test. We started with a 5-minute warm-up. And then participants completed stages until volitional exhaustion, starting at 7 miles an hour, increasing up to 9 miles an hour by stage 3. And then we increased the incline of the treadmill from there on until VO2 max or volitional fatigue. These were 2-minute stages. And on days 1 and 2, the shoes were worn in a random order between the 2 days. Then at least 48 hours later, on day 3, participants came back in for a submaximal test, specifically an absolute velocity running test, where we compared the 2 types of shoes. So they completed a 6-stage running test, each stage being 5 minutes long, and it was essentially 3 rounds of testing. So for the first round, they wore each type of shoe for 5 minutes at 7 miles an hour, for the second round at 8 miles an hour, and for the third round at 9 miles an hour. And then there was a 5-minute rest in between each stage in case they needed to switch between shoes. Then on day 4, they came back in for essentially the exact same test, but instead of running at absolute velocities or absolute speeds, they ran at speeds that were shown to or were intended to elicit a specific relative intensity. In this case, round 1 was 55% of VO2 max, round 2 was 65%, and round 3, 75%. So for our primary measurements, we collected, of course, running power, using pod. We always attached it to the right foot in this case. Then we also collected measures of metabolic demand, VO2 specifically, and then also calculated metabolic power from that. We also collected heart rate with a chest strap monitor, and then ratings of perceived exertion in the last 15 seconds of each stage. So for the statistical analysis, to compare measures during the absolute and relative velocity running tests, we conducted 2-way repeated measure ANOVAs, the 2-way being between 2 types of shoes, and then the repeated measures being across the 3 speeds or across the 3 intensities. And we did this for running power, metabolic power, VO2, heart rate, and RPE, and as well as speed for the relative velocity running test. Then to more specifically look at the relationship between these measures of metabolic demand and running power, we conducted a linear mixed model using data combined from the absolute and relative velocity running tests. We controlled for the random effect of participants, so we could then more specifically look at the fixed effect of the shoe type. We also conducted or calculated the standard error of the estimate to more specifically look at the regression model accuracy or the linear mixed model accuracy for estimating metabolic demand from running power. And then we expressed this error relative to the mean VO2 or the mean metabolic power during the tests. So for results, first looking at the absolute velocity running test, again, because speeds were supposed to be the same for both types of shoes, we expected the metabolic demand to be improved or lower for the high-end racing shoe, but we expected there to not be any difference in running power. So for metabolic demand, on the left graph, we see measures of oxygen consumption across the 3 types of speeds. And the red line representing the high-end racing shoe, you can see sits lower than the black line of the low-end economical shoe. And this was significantly lower. The same thing for metabolic measures of metabolic power across the 3 speeds, red line sitting lower than the black line of the low-end economical shoe. And on average, this was about 5.5% improved, 5.5% lower for the high-end racing shoe compared to the low-end economical shoe. We additionally saw this was a similar effect on heart rate as well. Now looking at running power, we saw no significant differences between the 2 types of shoes. So although a significant difference in metabolic demand at these 3 speeds, there was no significant difference in running power. So switching gears now to the relative velocity running tests. In this case, no significant difference would be expected for measures of metabolic demand, but we would expect the high-end racing shoes to be at faster speeds and therefore also running power as well. So first looking at metabolic demand, again on the left we have measures of oxygen consumption, on the right measures of metabolic power, and we see that the lines basically sit on top of each other. There's no significant difference in the metabolic demand between the 2 types of shoes as intended. Now for these 3 relative intensities for running power and speed, we did see a significant difference in the running power and the speed between these types of shoes. On average, running in the high-end racing shoe, they were able to run at about 6% higher running power, 6% faster speed in the high-end racing shoe for the same metabolic intensity, same metabolic demand. Now, when we combine this data from these two tests to look at this overall relationship between running power here on the x-axis, metabolic power here on the y-axis, we see that overall there is a linear relationship between these two variables. But you can see that these red dots and the red trend lines for the red dots of the high-end racing shoe sit on average a little bit lower for a given running power compared to the low-end economic shoe. And on average, this was about 5.5% lower metabolic power for the same running power in the high-end racing shoe. Now, we also saw that there was a bit of an interaction effect. So on average, the low-end, when wearing the low-end economic shoe, the metabolic power increased about 6% more as running power increased compared to the high-end racing shoe. You can see this more visually by seeing that the trend lines do sort of diverge a little bit as we increase in running power. Now, still, there was a very strong relationship within each shoe type, and particularly within subjects between running power and metabolic power. We can see when controlling for that random effect of participants, we had a very strong relationship, an R-squared of 0.98, and very little error. When you remove that random effect of participants, so reintroduce that variability between participants, the relationship does decrease a little bit, but it's still fairly strong at an R-squared of 0.8. But the error, again, does increase a little bit. So in conclusion, we can say that shoe type definitely influences the running power metabolic demand relationship. At least between these two types of shoes, we saw that metabolic demand was about 5 to 6% lower in the high-end racing shoes for the same running power compared to the low-end economical shoe. And there was no significant difference between the running power between the types of shoes, despite there being a significant difference in the metabolic demand required for that running power. Now, still within shoe types, there was a strong relationship between running power and metabolic demand, and this was particularly the case within subjects. The relationship was even stronger when looking at any individual on average. So the take-homes, the practical applications of this, we can say that at least under controlled conditions, runners and coaches and researchers can certainly use running power to indicate metabolic demand. But if you're going to be using multiple types of shoes or switching between types of shoes, they might need to adjust that target running power to maintain the same intended metabolic intensity or metabolic demand when switching between shoes. So I do have a few acknowledgments I want to make first. So thanks so much to all of our participants that gave tremendous effort during this study. Also, a very special thank you to Joseph Pastina and Isabel Gillis for their tremendous help during all of the data collection. They were pretty much there at every training or every testing session. And then a huge thank you to my dissertation committee as well for all of their support and guidance on this study. If you have any questions, please don't hesitate to email me. My email is right here on the screen. Yeah, thanks so much for listening. And yeah, please don't hesitate to email me any questions if you have any. Thanks.